We'll now consider the following example. The sides of an equilateral triangle are increasing at a rate of 10 centimeters per minute. At what rate is the area increasing when the sides are 30 centimeters long? First thing we do is identify this as being a related rates problem. You'll notice that they gave us a rate in the form of a rate of 10 centimeters per minute, and we were asked once again at what rate is another quantity changing. So we are trying to relate these two rates together. So what we have here is an example of an equilateral triangle whose sides are magically increasing. So this one will go that way, this one will go this way, and this one will, well, it'll go both ways. So as soon as we hit the instant that these are 30 centimeters long, with all of these rates being 10 centimeters per second, 10 centimeters per minute, question is how quickly is the area increasing? Now, from pre-calculus, we have a number of different formulas for the area of an equilateral triangle. I would say, let's define a variable. We'll say let S be equal to a side length. Then what I'm going to recommend that we do is relate the side length with the area through the use of the side angle side formula for the area of a triangle. So the area of the triangle, let's say A is the area. The area is going to be equal to 1/2 times the product of any two consecutive sides, so S times the sine of the angle between them. And it's well known for an equilateral triangle that all three of the angles have to be equal as well, and that'll be 60 degrees. So we'll have 1/2 of S squared times the sine of 60 degrees, which is the square root of 3 over 2, which gives us the following formula. This will be root 3 over 4 times S squared. Now, A is changing over the course of time, S is changing over the course of time. Let's find out how they are related to each other. So I'm going to implicitly differentiate both sides with respect to t. Now over on the right hand side, the root 3 over 4 is a constant multiple, so we'll just need to worry about the S squared. On the left hand side, A is another variable, so that'll just be dA over dt. On the left hand side, once again, this will be the square root of 3 divided by 4 times derivative of S squared with respect to S would be 2S. With respect to t would be 2S times ds dt. Now, we happen to know both of these quantities, so let's plug them in. The rate at which the area is increasing is going to be equal to root 3 over 4 times 2 times S. We were told that the instantaneous side length would be 30 centimeters, and the rate of increase is 10 centimeters per minute. Multiplying these three quantities together would give us, 600. 600 divided by 4 would be 150. So final answer for this one is going to be 150. We took a centimeter times a centimeter per minute, so that will have units of centimeters squared per minute. There was no solving that we had to do since we already had dA over dt by itself on one side as we got started. Pardon me, that was 150 square roots of 3 centimeters squared per minute. Final answer.